Hi, welcome to my channel Education for Aspirants. Today I am going to discuss the complexity analysis of quicksort. Before moving to understand the concept of analysis part, one must first know what is the process of quicksort. So without delay, let's move to discuss the different functionality of quicksort first. You know guys, quicksort always follows divide and conquer method. Means each time it will divide the whole structure into two parts. To divide the whole structure into two parts, it will use an algorithm that is called as partition algorithm. So guys, here in quicksort method, it will use a pivot element, and by the help of pivot element, the partition algorithm will help to divide the structure into two parts. Clear? Then after dividing the array into two parts, it will call to the left part and right part recursively. Now let us assume one case where the whole array has divided into two equal parts by taking the pivot at exactly mid location. If total number of elements are n, then in the left side of pivot n by 2 elements will be there. In the right side of pivot also n by 2 elements will be there. Then further it will divide these two substructures with containing n by 4 number of elements. Why n by 4? Because previously each substructure contained n by 2 elements. What is the main case here? Though every time it is dividing the whole structure into two parts, that's why here we require minimum number of levels to stop the partition procedure. That's why we can consider to this case as a best case of the quicksort method. Now we'll consider the worst case of the quicksort method. Assume that inside the array all the elements are present in a sorted order. So let us consider, we will consider the pivot element to the last element. So by taking the pivot element, and with this element if you start comparison, then what will happen? The location of pivot will not change. So here it will divide the total structure into two parts by taking all the elements inside the left array, and right array is totally. Similarly, in the next iteration also, you will choose the last element as pivot, and it will divide to the whole array into two sub arrays where all the elements will present into the left sub array, and there will not be any element inside the right sub array. That's why normally we are considering to this case as a worst case of the quicksort method. Now we will discuss these two cases with an example. Let's consider an array with n number of elements given for sorting process. For the best case analysis, we will assume that every time the partition method will divide the whole array into two equal subarrays by considering the pivot element at exactly middle location in the array. Clear? So in this case, after applying the divide and conquer procedure, the partition method will divide the whole array into two equal subarrays of n by 2 number of elements in each. So here n by 2 number of elements, here n by 2 number of elements, right? At the first level, the partition method will place the pivot at the middle location, and with this pivot location, it will divide the whole array into two equal parts, right? Now, at the second iteration, both the left and right subarray process recursively, and they further divide into two subarrays of n by 4 number of elements in each. So see here that left subarray further processed into two subarrays with n by 4 and n by 4 element. Here also a right subarray processed into two subarrays with n by 4 and n by 4 elements, right? You know that in a tree, the number of subarrays present we can find out by using the rule that is 2 to the power L. So what is L here? L represents level number, right? So here level number is 1. So here if you see 2 to the power 1, that equal to 2. So you can observe here two subarrays present. Similarly, coming to the second level, so here the level number is 2. that is 2 to the 2 equals to 4, and you can see here in the second level 4 number of sub arrays are present. In the third level, how many sub arrays will come? 2 to the power 3, that is 8. So in the third level we will get 8 number of sub arrays, right? Though the partition method processing each sub array recursively, hence it is forming a recursive tree. Now the question is, when the partition method will stop the divide process inside the recursion tree? As per the quicksort algorithm, the partition method will stop the divide procedure only when each subarray will contain one element, right? So let's assume that in this recursion tree, the partition method will stop the divide process at kth level. It implies that at kth level, each subarray will contain one element, right? So see here in this figure, so every means subarray contains one element, right? As per the rule, the number of elements present in a subarray can be found out by using the formula, that is number of elements present in a subarray equals to total number of elements divided by number of subarrays present in that level. For example, we will find out in the first level. So in the first level, the total number of element is n divided by, so total number of subarrays present. How many subarrays present in that level? That is 2. So we can write n divided by 2. Clear? See here, every subarray contain n divided by 2 element. Similarly, in the second level, we can find out total number of element is n divided by total number of subarrays present in that level, that is 2 to the 2. So we will get n by 4. So see here, every subarray contain n by 4 elements. Like this, in the third level, how will you find out? N divided by 2 to the 3, that equal to n by 8. Clear? So in this way, though you assume that the partition method will stop the divide process, hence we can write that n by 2 to the power k equals to 1. Clear? What is 2 to the power k? 2 to the power k represents number of subarrays present in the kth level, right? Now we'll find a solution. If n by 2 to the power k equals to 1, why it is 1? Because you know that each subarray contain one element. So that's why n by 2 to the power k equals to 1. That implies n equals to 2 to the power k, right? Put log in both sides. If you put log in both sides, log n equals to log 2 to the power k, right? Then solve it, equals to, we can write that is k log 2 base 2, and you know that log 2 base 2 equal to 1. So we can write k into 1. Clear? That implies log n equals to, we got k, and we can, or k equals to log n. I hope understood. So what is k? K is nothing but it is the level number, right? Means we concluded that inside the recursion tree, it will take log n levels to stop the partition process, right? I hope understood. Now we will calculate the analysis part. See here. So here, how many levels we required? Log n levels, right? To stop the partitions. Now we'll discuss the time complexity of the quicksort. So we can find out the time complexity by calculating total number of levels multiplied by total number of comparisons in each level. Now we'll see, when n number of elements are there, how many comparisons you required here? N comparison. Then in the first level, the total number of comparisons required how much? N minus 1. Because that is n by 2 plus n by 2 minus 1. What is minus 1? Minus 1 is your pivot. When you will come to the second level, how many total number of comparisons required? So here also total is n, and you have taken 2 pivots, right? So that's why we can take n minus 2. Similarly, in the kth level, how many comparisons you required? The number of comparisons required is n minus k. So here when we are finding the complexity, that 1, 2, k, these constant values we are not considering. Hence, we will consider the total number of comparison as C of n. Clear? C is a constant value. I hope understood. Then now we will find the time complexity. In the recursion tree, how many number of levels required to stop the partition? That is log n levels. Then each level contain how many comparisons? That is n comparisons, nearly n comparisons. So find the time complexity. Time complexity equal to total number of levels, that is log n, and total number of comparisons required n. Clear? So that is complexity equal to n log n, and it is big O of n log n. I hope understood. This is the total time complexity in best case for the quicksort method. Now we will consider the worst case. You know guys, when the elements inside the structure are present in a order, at that time we will consider to this case as a worst case complexity. As per the rule, I will consider to the last element as a pivot element. So by considering the pivot element, if you will divide to that array into two parts, the left array will contain 2, 3, 4, 5, 6. Then 7 is the pivot. Then in the right array, there will not be any element. Similarly, in the second stage, you will consider 6 as pivot, and it will divide to that array into two parts, where the left array will contain 2, 3, 4, 5, and right array will not contain any element. Similarly, in the next level, if you will consider the 5 as a pivot, then it will divide to that array into two sub-arrays. One left sub-array will contain 2, 3, 4, and right sub-array will not contain any element. Okay? So in this way, if you will continue the procedure, in the next iteration, left sub-array will contain 2 and 3, then right sub-array will not contain any element, right? So then you will divide, then you will get 2 as left sub-array, then 3 as a pivot, then after that there is no element present inside the right sub-array. In the first level, how many comparisons required here? N comparison. Then come to the first iteration. After completion of the first iteration, how many comparisons you required here? That is n minus 1 number of comparison. In the second iteration, how many comparisons required? That is n minus 2 comparisons required. Similarly, in the third stage, how many comparisons required? N minus 3 comparisons required. In the fourth stage, n minus 4 comparisons required. Then, in the last stage, how many comparisons required? N minus 5 comparisons required. I hope understood. So, as per the rule of time complexity, total number of partitions multiplied by total number of comparisons. So here in each stage it is dividing to that array into one partition only, because the right sub-array is totally empty. So total number of partition equal to how much? Only 1, and it is multiplied by every time the number of comparison. Clear? So first time it is multiplied by n minus 1, then second time n minus 2, third time n minus 3, fourth time n minus 4. Like this, it will come to 2 comparisons. Now you find what is the value of this series. The value of the series is n into n plus 1 divided by 2, and it is multiplied by 1. Now if you will solve it, you will get here n square plus n divided by 2. You know that when we are finding the complexity, we are just neglecting to the constant terms. So that's why we will consider here t of n equals to n square plus n, and in between these two factors, so here highest factor is n square. That's why we can write the complexities, that is t of n equals to big O of n square. For example, let instead of 7, we will consider the first element as a pivot. If we will consider the first element as a pivot, then what will happen? The left array will become empty and all the elements will come to the right sub-array, right? I hope understood. So in this way, the right sub-array gradually it will increase. Here also, after solving, you will get the same number of complexity, that is n square. Clear? What is the best case of quicksort we found? That is n log n. Similarly, what is the worst case we found? That is big of n square. I discussed all the concepts, how to find out the complexity of quicksort algorithm in best case as well as worst case. I hope everybody you understood it. Thank you.